I guess this is important to also realize. So function sine and other functions have this special so-called library for their graphs. And this library, one just needs to be familiar with, just like if you're familiar with graph of parabola, right? Or graph of cubic parabola or a square root function. So these things you, I guess, working with in order to get those little graphs produced. So how can I get some of these sine functions graph? So I'm gonna do a couple of problems with sines today, and then next time we'll look at cosines. So let me go to the exercises. Turns out the key part is to put this so-called main wave of this function down correctly. Because once you have this piece that I just graphed in between of 0 to 2 pi, well, that's good enough because you can repeat this a few times to the left and to the right, and that's all really needed. So let me try another exercise with function sine, exercise 37 here, that says, how about if you try to graph negative in front? So if you graph 37, this is -4, which is multiplied by that sine of x. Well, if you remember that when we graphed, let's say, parabola x squared, then multiplying this x squared by negative would do nothing but reflect the graph through x-axis. So that's good to realize because this graphing techniques is the same for our function -4 with a sine as well. In other words, my graph of function sine, this main wave, is going to look like that. So instead of going upwards here, it goes downwards because it's flipped. And it's still in between 0 and 2 pi. Well, it turns out it's multiplied by 4, and that's why we have so-called amplitude changed. So it used to be between minus and +1. Now, since it's multiplied by 4, well, it'd be in between minus and +4. Just like that. I guess sometimes people calculate points, and that's very annoying and tedious. And the goal is not to do that. The goal is to just look at the graph and right away decide what happened with your basic function sine that you actually had worked with. So let me try one more here, number 43 with a sine. As I said, I'm not going to continue. I think it's already plenty for you for the weekend because this book is quite concentrated in terms of material, so I don't want to overwhelm you. And in fact, we are in a very good shape covering the material. So I'm going to multiply now by 3. Right? Actually, once Alex, it's not 3, it's 2. Okay, I should be careful. Multiply by 2. And it's 1/2 x. Okay. So it looks like when I multiply by 2, it's going to be analogous to multiplying it by 4. So the graph of function sine is again going to be in between -2 and +2. So that so-called amplitude, whatever is multiplied by your sine, will give you upper and lower borders. Now, here's one extra thing to watch out for, and this will be take our whatever argument of function sine is, and that's 1/2 x, put it in between 0 and 2 pi. That's a standard procedure, because when I originally graphed my function sine, I had to go from 0 and to 2 pi to get that wave. So now I need to see what's happening with x, because it's 1/2 times x. And what happens with x, I just need to multiply by 2 everything, so I can pull out x from the middle. So it'll be in between of 0 and 4 pi. So it turns out my period changed. It was 2 pi, but now it is doubled. It is 4 pi. And it continues to the left and to the right, and this is it. So I would say this is good enough for you to look at over weekend, because once you get used to these ideas, the graphing will go faster, because it's just same thing for all of them. So try to redo the same problems that I just done for you today. I'm talking about this graphing little exercises. And then we're gonna continue on Monday next week. So I hope that you're going to have a good weekend. I don't give you a quiz today, so just let you go without. We had a quiz last time, so I think it's good enough. So I'm gonna stop this recording and